Welcome to Concepts in Chemistry. In this talk, we will discuss how matter is classified in chemistry. How can matter be classified? Matter can be classified in two ways. One is by state, and the other is by composition. So let's look at how matter is classified by state. Matter can be classified into three states. These states are solid, liquid, and gas. Now, how are the atoms or molecules arranged in a solid, liquid, or gas? Usually in a solid, the atoms or molecules are closely packed. In a liquid, the molecules are not as tightly packed as we have in the solid. In a gas, the molecules are widely spaced. So as you can see these particle models. So these particle models are just illustrating how the atoms or molecules are arranged or packed in a solid, liquid, or a gas. Okay, so just by looking at these particle models, you notice that gases do have lots of empty spaces between them, okay, followed by liquids and then solids. Now, what are some of the properties of these three states? Now, if you imagine putting a solid in a beaker, you notice that the solid doesn't take the shape of the beaker. The solid holds its shape. Okay, so one of the properties of solids is that they have a fixed shape. Okay, they also have a fixed volume, as you can see. Now, if you put a liquid in a beaker, you notice that the liquid takes the shape of the beaker. Okay, so this tells you that liquids do not have a definite shape. Though they have a fixed volume, they do not have a definite shape. They usually take up the shape of the container. Okay. Gases are usually invisible, but usually gases fills up whatever container you put gases in. So they fill up the whole space because the molecules or atoms of gases are always moving about randomly and fills the whole space. Okay. So gases do not have a fixed volume and they do not have a fixed shape. Okay. Because of the loss, because they do have lots of empty spaces between them, they can easily be compressed. Okay, so they take up whatever container you put them in. Okay, which is why we are able to pump air into our car tires to be able to drive them around. We compress these air molecules into the car tire. So these are the three states of matter. Now let's do a little bit of an exercise here. So we want to go through the properties again. So what are the properties of the three states of matter in terms of volume, shape, flow? Can they easily be compressed? And at the molecular level, how do they appear? And then with respect to kinetic energy and attractive forces, which one dominates in which state? Okay, so let's look at this table here. So these are the properties that are being asked in this table, and these are the states. Okay, so for volume, what we need to do, we just have to go through these questions. Has it got a fixed volume? So solids, yes, do have a fixed volume. Liquids, yes, do have a fixed volume. But gases do not have a fixed volume. Okay. Now, has it got a fixed shape? Solids do have a fixed shape generally, though we have exceptions. Liquids do not have a fixed shape. Usually liquids take the shape of their container. Gases also do not have a fixed shape. Okay, they take the shape of their container. Just imagine blowing air into a balloon. Okay. The air molecules takes the shape of the balloon in this case. Flow, can it easily flow? Solids, no. Liquids, yes. And then gases, yes. Now, can it easily be compressed? Solids cannot easily be compressed. Okay, liquids also cannot easily be compressed. You can demonstrate. If you're not sure about liquids, just get a syringe, draw some liquid into the syringe, and then try to compress it, and then see if you can. Gases, yes, gases can easily be compressed, and there's a reason why we are able to compress gases easily because of lots of empty spaces between the atoms or molecules of a gas. Okay, so yeah, even though we have spaces in liquids and solids, but it's very difficult. These spaces are not as large as we have in a gas, which is why solids and liquids are not easily compressible. Okay, so in terms of attractive forces and kinetic energy, how do they play out to make things appear as solids, liquids, or gases? So let's go through. So usually in solids, the atoms are closely packed, or the molecules are closely packed. Now, the reason being, the attractive forces between the molecules is so strong that is greater than the kinetic energy, which is why the molecules are really held in fixed positions. Okay, so in solids, attractive forces dominate kinetic energy. Okay, in liquids, if we imagine water, we are able to pour water out of a container. So the molecules of water are able to slide over each other and so on. So we normally say the kinetic energy in liquids is slightly greater than the attractive forces. Okay, so now gases, as we've experienced, we can see gas, and gas molecules are always moving about randomly. Okay, so we usually say the attractive forces between gas molecules is really small, such that you can ignore it. So we normally say the kinetic energy in gas molecules is far, far greater than the attractive forces between them. Okay, so yeah, so that is the interplay of attractive forces and kinetic energy in each of these states. Okay, so I want to repeat. So in solids, attractive forces is much greater than kinetic energy. In liquids, kinetic energy is slightly greater than attractive forces. And in gases, kinetic energy is far, far greater than attractive forces. Okay. Now, how can matter be classified by composition? We've looked at classifying matter by state. So now let's look at how matter can be classified by composition. Now, in terms of composition, matter can be classified based on whether it's a pure substance or it's a mixture. So normally, this is just a flow diagram here that really helps with this classification. So first, if you have a piece of matter, you ask yourself, is the composition of matter uniform and constant throughout? So is the makeup of it uniform and then constant? If the answer is yes, then you are dealing with a pure substance. Okay. If the answer is no, then you are dealing with a mixture. Okay. So the reason being, you can have a substance that is uniform throughout, but the composition is not constant. Okay. So for instance, if you have a solution of salt or a solution of sugar, now it is uniform throughout, but just that it has not got a fixed composition. Because if you sample anywhere in the solution, there is no guarantee that you are going to get the same concentration of water and sugar molecules or water and salt molecules. Okay, so we normally say a mixture has no fixed composition. Okay, yes, so if the composition is uniform and constant, then you are dealing with a pure substance. And once you have a pure substance, the pure substance can either be an element or it can be a compound. Okay, now if the pure substance is an element, then that means that it consists of the same type of atoms. Okay, so if you're looking at argon, argon consists of the same type of atoms. So the element argon is a collection of what? Argon atoms. Okay, so that makes it a pure substance. Okay, now if your pure substance consists of at least two different atoms bonded together, then you are dealing with a compound. Okay, you are dealing with a compound. So a compound consists of at least two different atoms bonded together. Okay, so Yeah, so if you have a pure substance, your pure substance can either be an element or a compound. Okay, so this is a particle model of an element. So as you can see, this element is depicting argon, and the particle model shows atoms of argon. So this is just saying the element argon is a collection of what argon atoms. Okay, so which makes it a pure substance. Now, if you look at a compound consists of at least two different atoms bonded together. So as you can see here, this particle model is depicting carbon monoxide. Okay, so in carbon monoxide, you have carbon and oxygen. Okay, so there are two different atoms bonded. So this makes it a compound, but it's still a pure substance because it consists of what? Carbon and oxygen atoms bonded together to make carbon monoxide. So it's carbon monoxide throughout this particle model. So, and it has a fixed composition and it's uniform. So which makes it a pure substance. Okay. Now, if it's a mixture, then that means that the composition is not constant. The composition is uniform but not constant. Okay, so which means that a mixture also can be heterogeneous or homogeneous. Okay, so if a mixture is uniform in terms of having the solute and solvent evenly distributed in solution, then we are dealing with a homogeneous substance. Okay, so an example of a homogeneous solution is water and sugar molecules, water and sugar solution. Okay, and an example of a heterogeneous mixture is oil and water. So yeah, so this particle model here is depicting a heterogeneous solution. So as you can see, you have a layer of different molecules on top or atoms on top, and you have another layer of atoms or molecules, okay, below the red one. So this is just saying that you have, so if the bottom here depicts water, if the dark circle depicts water, that means the top layer depicts what? Oil. So this is just showing that there's a separation between the two layers. So you don't really have, they are not uniformly mixed in this case, which makes the solution heterogeneous. Okay. Now, if it's homogeneous, it means that the solutions are uniformly, the components in the solution are uniformly mixed. Okay, so an example is sugar and water solution or salt and water. So you see the dark and red circles are uniformly distributed in this box, so describing a homogeneous solution. Now, this is another way of classifying matter by composition. Okay, it's still a flow diagram, but just that it's a little bit, the way it's organized a little bit different, but it's, yeah, they're comparable. So let's go through it. So if you have piece of matter, you ask yourself, is the composition and properties of matter uniform throughout? If it's yes, as you can see here, you don't have constant composition. You just have, is the composition and properties of matter uniform throughout? So if it's uniform throughout, then that means that it's homogeneous. Okay. Now, if it's homogeneous, it can either be a pure substance or a homogeneous mixture. So if it's homogeneous, you ask yourself again, is the composition definite and constant? Has it got a fixed composition? If yes, then you are dealing with a pure substance. And once you have a pure substance, you ask yourself again, does this pure substance consist of at least two different atoms bonded together? If the answer is yes, then you're dealing with a compound. If the answer is no, then you're dealing with an element. Okay, so, and here you do have carbon monoxide again, as we saw before, and here you do have helium, which is an element consisting of a collection of helium atoms. Okay. Now, if the composition is uniform, but it has no constant. Now, if the composition is uniform but not constant, then that means that you are dealing with a homogeneous mixture, okay, which means a solution. So an example is the water and sugar solution, or salt and sugar solution. Now, if the composition is not uniform at all, then you are dealing with heterogeneous. Okay, so here, if it's heterogeneous mixture, then you do have an example is the oil and water or the sun and water mixture. Okay, so yeah, so that's another way of classifying, but you have to pay attention to the questions in the diagram. Okay, so here it says, is the composition and property of matter uniform throughout? Here you don't really see constant composition, you only see uniform. Okay, which means that it's either homogeneous or hetero, and then you proceed. Okay. So once you pay attention to that, yeah, it's similar to the diagram we looked at already. Okay, so now let's try to go through these definitions and then try to match them to the terms above. So we want to read these definitions and then we map them to the terms here. Okay, so definition 1 consists of the same type of atoms. Okay. So if it consists of the same type of atoms, then you're dealing with an element. Okay. And then definition 2, the smallest piece of an element that has the chemical properties of the element and can take part in a chemical reaction. So you're dealing with an atom. And 3, when at least 2 different atoms are bonded to form a substance with fixed composition. So here you are dealing with a compound. When definition 4, when chemicals in a mixture are not uniformly distributed throughout the mixture. So here you are dealing with heterogeneous. And definition 5, when chemicals in a mixture are uniformly distributed throughout the mixture. So here you are dealing with homogeneous mixture. And definition 6, when a substance consists of the same type of chemical with fixed composition throughout. So here you are dealing with a pure substance. Now, when 2 or more, definition 7, when 2 or more atoms are bonded together, and it is the smallest piece of a compound. So here you are dealing with a molecule. A molecule. Okay, so a molecule is when you have 2 or more atoms bonded together. The atoms don't necessarily have to be different. Okay, they can be the same atoms or different atoms. Okay, so once you have 2 or more atoms bonded together, you're dealing with a molecule. And usually a molecule is the smallest piece of a compound. Okay. When 2 or more chemicals are intermingled with one another. So here you are dealing with a mixture. Okay. So let's try to draw particle models to depict these definitions. Okay. So we've already looked at some, but let's try to draw them. So what is a model of an atom? So an atom, we usually use we draw a sphere to represent an atom. So this is an atom. Okay. What is an element? An element is a collection of the same type of atom. So here, as you can see, it's the same type of circle repeated. So an element just consists of the same type of atom. Okay, so the collection of the same type of circles, which means the collection of the same type of atoms, okay, which makes an element. What is a compound? Now, a compound is when you have at least 2 different atoms bonded. Okay, so here you have carbon and oxygen bonded to make carbon monoxide, and here you have hydrogen and oxygen bonded to make water. Okay, so these are compounds because you do have carbon atom and oxygen atom, so they are different atoms, and you do have hydrogen and oxygen, they are different atoms too. So once they unite, they make a compound. And what's heterogeneous mixture? So heterogeneous mixture is when the components of the mixture are not uniformly distributed. So here you clearly see that these particles or molecules are not uniformly distributed. Okay, you have a layer sitting on top of another layer. Okay. And what's a homogeneous mixture? So a homogeneous mixture is when the particles are uniformly distributed. So if the blue circle represents one component of the mixture and the yellow circle another component of the mixture, and they are all uniformly distributed, then we are dealing with a homogeneous mixture. So an example is sugar and water. So if the blue circle represent water molecules and the yellow circle represents sugar molecules, and they are all uniformly distributed, then we are dealing with a homogeneous mixture. And what is a molecule? Okay. Now, a molecule is when 2 or more atoms are bonded. The atoms don't necessarily have to be different. Okay, so here, this is a molecule. So you have 2 atoms of the same type bonding. So that's a molecule. This is also a molecule. Okay. But the bottom one here can also be a compound. Okay. So the smallest piece of a compound is a molecule. Okay. So, but this also a compound. Okay. So a compound is when you have at least two different atoms bonded. So this is a compound, but it can also be a molecule if you have a collection of several compounds. Okay. So just, yeah, so the smallest piece of a compound is a molecule. And what's a pure substance? So a pure substance is when you have the same type of substance throughout with fixed composition. Okay. So yeah, so the particle model of an element here depicts a pure substance. So that's a pure substance. Okay. Yeah. And it can also be a compound. So a pure substance also can be a compound. A compound will consist of a collection of what? The same type of molecules with fixed composition. So making it a pure